All right, good morning. Let's see, we got sound, it looks like, hopefully. All right, good morning. It looks like we picked up some followers on Twitch yesterday. I didn't stream, but thanks to Gary Meg and Blue Room on Twitch for follows. Get that, my friends. If you happen to see this, that's super awesome. In any case, it's awesome that you followed. Let's go. Here, let me this one and turn off this preview. Get a swig of coffee and then we'll find the browser and get the show on the road. So yes, welcome. First of all, thanks for anyone watching. If you are new and you don't know, haven't seen this before, my name is Tim. I go by Foamy Guy on GitHub and Discord, and I usually stream at this time each week around 10 a.m. Central Time, working on stuff related to CircuitPython. If you don't know what CircuitPython is, you can learn more at the main website for it, circuitpython.org. It is basically a version of Python that runs on tiny computers called microcontrollers. These devices, when you use CircuitPython to program them, typically the way it works, you plug it into your computer, it shows up like a thumb drive. You can edit some Python code that's on that thumb drive. And when you save it, the microcontroller will actually execute the Python code for you. And then the code itself can interact with whatever other peripherals you happen to have connected to your microcontroller. Some of these devices are very general, where they have lots of I/O pins. You can connect whatever you want. Others are more purpose-built, where they have specific sets of built-in hardware. The MagTag has an e-ink screen. The MacroPad has some Cherry MX keys, or compatible. I don't know if they're actually Cherry brand or what. And a knob and some other stuff. So different ones of these devices fit different use cases. The 602 of them that are here all run CircuitPython, which is typically what my streams are centered around, albeit somewhat loosely, because today what we are working on is actually over in the Blinka land. Blinka is the CircuitPython compatibility layer for Raspberry Pi and other single board computers, as well as MicroPython, which is why there are other microcontroller devices that are listed here. But the things that are most relevant to what I am doing today are things like the Raspberry Pi, Raspberry Pi 4, Raspberry Pi 5, Raspberry Pi 3. So Blinka is a Python library, a CPython library that runs on, quote unquote, normal computers, not microcontrollers, such as the Raspberry Pi. What it does is it gives you a layer that essentially implements the same API as CircuitPython, or that's what its intention is, so that you can then have code that is written for CircuitPython to run on these microcontrollers over here, and you can instead run it on a Raspberry Pi here. That is what Blinka does, and that is what we are working on today. And even more specifically, we are getting into Blinka DisplayIO, which is the DisplayIO module for Blinka. So having the ability to run on those Raspberry Pi computers and output to a display. Blinka DisplayIO itself, typically that display is going to be connected over SPI or I2C, just like it would be on a microcontroller. Although, as you'll see when we dive into it, I am actually running with a separate thing as well that's allowing me to do it on the PC. Before I jump in, let's say one more thing. As always, thanks to Adafruit. If you would like to help support CircuitPython, as well as the Blinka compatibility layer, and all the folks like me who work on it, one of the easiest ways to do that is purchase hardware from Adafruit. Adafruit is a hardware and software company based out of New York that makes lots of little hardware devices like the microcontroller boards, as well as all sorts of other add-ons and things that you can do with your microcontrollers. And Adafruit pays the folks, a core team of folks who work on CircuitPython, as well as that Blinka compatibility layer, including myself. So huge thanks to them for making it possible by paying myself and the rest of the team. And then huge thanks to everyone who purchases hardware from them, because obviously that is what is keeping the whole thing running. If they don't sell hardware, they cannot pay us, and so on. Okay, so where I would like to jump in today is bitmaptools for Blinka DisplayIO. There is an issue for it that was filed a while ago, and I am now motivated for various reasons to work on it. So that's what we're doing. I have, like I was saying, I have this other thing, Blinka DisplayIO Pygame Display. So this is a add-on that works with Blinka DisplayIO, and what it does is it essentially gives you a virtual display. So we go to one of these demos, we can see this code here creating a display object. In CircuitPython, you might see code like this where you're initializing a display, but you would be passing it like a SPI bus or an I2C bus, and you would be passing it, a init sequences maybe, or arguments that ultimately find their way into init sequences. What this library, Pygame Display, does is it creates a display object that Blinka DisplayIO sees and treats as a display object, just like a SPI display or anything else. But instead of actually connecting to SPI or any other hardware, it is using Pygame to just draw a window on the PC that it's running on. So if I run this one, it will pop up a Pygame window, and then it will run the DisplayIO code, and it will output the results into that Pygame window as though it were a display. So that is what this library is all about. And I made this a while ago. Let me pull up the GitHub for it. I made this a while ago, but it did languish for a while. Essentially, when Blinka DisplayIO was updated to 1.0 or maybe 2.0. I'm not sure which, but at one point in time, Blinka DisplayIO was updated. I think it was 1.0 even. And it became incompatible with this library. And then I have done work a few different times to try to get it working, and I never got it fully working. The place where I last left it off was I had it working either for manual refreshes or auto refreshes, but I could not get both working at the same time. And then I picked this up the other day. Somebody was asking about it in the Discord or something like it. Was asking about a thing that does this essentially, and it got me thinking about it a bit more. And I went back and looked at some of the branches that I had done work on a while ago, and realized that they were further along than I remembered, and that I think it's worth it to go ahead and get this updated to work, even if I can't get both manual and auto refresh working. So what I've done just 2 days ago, I did a big PR and merge that brought in a bunch of changes to basically remove the auto refresh support, fix everything that needed fixing to work with the newest version of Blinka DisplayIO, which is actually on 2.x. I don't know the exact version, but they have passed 1.0 to 2.0. And now Blinka DisplayIO Pygame Display only supports the manual refresh. So inside your code, you need to have display.refresh, or else it will not get drawn on the screen. At some point, auto refresh support may return, but it is going to take some work with the threads and the updating of the Pygame display. One of the things I found when I picked this back up is that Pygame display, I don't know if this is new or if somehow we were getting around it before, or if I figured it out in the past or what, but Pygame display doesn't like to be updated from the background. For Pygame stuff, you have to call display.flip or something like that to get it to like refresh. That's like Pygame's version of refresh, and you can't call that from a background thread. And so auto refresh is a very tricky thing to try to implement because it's trying to run in a background thread, but it can't actually do that. There needs to be some kind of main thread hook or else some construct that I'm not aware of that somehow allows it to kind of jump threads when it needs to do the final flip. In any case, I did go ahead and remove auto refresh. It's now manual only. PRs are welcome if anyone happens to see this and wants to work on bringing auto refresh back. That'd be super cool. I'd be more than happy to help you out. If you have questions about the library or how it works, or if you obviously leave a PR, then I'm happy to review. But with that, we're going to jump in. I am just going to use this to work on bitmaptools because this is convenient. I can just run it on the PC. I don't actually need the Raspberry Pi all set up. And I am going to start by just making a test thing here. So I'm just going to call this bitmaptools test. And we're going to do a couple of simple setup things. So this setup script that I just copied has initializing the display, making a main group, and setting it to the root group on the display. Calling refresh here, and checking for the exit button on the display as well. This differs from CircuitPython, obviously, because there's no exit button on a physical display. What's up, Tyth? UI changes from the main thread only annoying. Yeah, totally. That's the it's the same deal. Like Android is the same way, which is what a large part of my background was. But in Android, there are constructs that help you work around it, and I don't know that those things may exist for Pygame display, but I'm not. Don't have enough experience there to know what they are or how to use them. And then what happened is Blinka DisplayIO itself got updated to use threads. Pygame Display, a community member had added auto refresh support by using threads a while back, even before Blinka DisplayIO started using threads. And then Blinka DisplayIO started using threads, and now there's like two different ones, both kind of trying to do display stuff. And it got all crazy. I could not figure out how to get it working. I'm sure it is possible, but it may require, like, I don't know, there might have to be another API change. There might have to be another hook or something. I'm not entirely certain. Like a process refresh queue or something. Maybe the actual preparing of the buffer takes place in the background, but the final refresh is on a queue system from the main thread somehow, but I don't know. For now, I will go manual and work on just kind of adding more features to the rest of Blinka DisplayIO. So I will want a bitmap if I'm going to be testing Blit. Feeling very creative on the name, so we're just going to call it BMP. You can import that. Actually, we already have DisplayIO, so I guess we'll just use that. DisplayIO. That takes, I think, X, Y, and then the number of colors, so we'll just go with the whole display for now. That's another nice thing about this running on a PC. I can use, like, big screens, and I don't care if I have bitmaps that are the full size. Like, we have infinite memory, essentially, as far as CircuitPython is concerned. Colors, let's get it some colors. I don't know exactly how many we'll want in the end, but load it up with some at least. We can use a palette for that. We do need to load the palette with 16 colors. I think I want 0 to be black, actually. Do 1 as white, and then we'll do, I guess, 14 of them as their colors, but start going through these. Maybe I won't use all of the slots. Do those for now. We need a tile grid so that we can show it. DisplayIO. Shader, yes. Okay, we want to add that to the main group. And so right now it's going to be all black, which means we're not going to be able to see anything. Let's just draw something on it. In fact, actually, we can just fill it. Let's do that. bmp.fill. Let's fill it with green, so 3. Then run this. All right, there we go. Okay. What is this? Oh, I think I left this in my version of this, trying to fix something else. I'm just going to comment this out for right now. I'm surprised that that's not like crashing harder, actually, but I don't know. I'm surprised that's not crashing harder. It's trying to do time.sleep kind of a lot, and it wasn't imported anyway. Okay, so bitmaptools. Let's get another thing open, which is the docs for bitmaptools. I am gonna start with easy ones, and I think the easiest one is probably fill region. Draw a line, maybe. Reads from a binary file? Huh. I don't know about this. I've never seen this one used, I don't think. Sure, I understand where this would, like, what would use this. I guess if you know the header information of your bitmap, then you can save time by ignoring the header and using hard-coded values. Maybe that's what I'm understanding from that. Or if that's actually right. But I think I will definitely start with fill region, draw a line, draw a circle. Maybe we could do pretty easily, I think. Draw a polygon, maybe. That's getting a bit harder. So one thing is we can look at the C code for these, but it is split across shared bindings and shared modules. And then like alpha blend, I don't have any experience with. I'll have to figure out what that does. I think rotozoom is kind of like the boss for this module, the boss fight. Rotozoom is kind of like does everything. It's basically a version of Blit that can also modify stuff it's copying in various different ways. Blit will actually be fairly easy as well. There's already Python implementations of that in a few places, I think. Okay, so fill region is basically just make a rectangle, and where'd it go? The most naive implementation is just 2 for loops. Do bitmaps support slicing? That's probably just going to be using a for loop inside, though. Another thing that we could open actually is Blinka DisplayIO itself, because it might be nice to look at implementation of bitmap. I don't actually have. Oh, because it's Adafruit Blinka DisplayIO. I did the main and update. Set item. Like that is supporting slices, as far as I understand it. Actually, there's one of the Python implementations of Blit, in fact. Okay. In fact, we could make a branch. Bitmap tools. Destination. So, yeah, again, the most naive one is just 2 for loops, right? So we go for, I'll do y on the outside for y in range from y1 to, this says y2 plus 1. So is it inclusive or exclusive? Exclusive. So we do not want to add 1 to this because that would make it inclusive. We go loop from y1 to y2, we go loop from x1 to x2, and we go destination bitmap at xy equals value. All we need to go back to here, and let's get it so that we have that Blinka DisplayIO that I'm editing as the one that's installed. I'm gonna say pip uninstall Adafruit Blinka DisplayIO. It's gonna make this not work. And then we're gonna go up DisplayIO pip install -e, which is gonna make it, I don't know what E stands for, but it's gonna make it like stay in sync. As soon as I modify a file over here, it will be reflected in the one that's installed in this virtual environment. Basically, it will use the code as the install directory, I guess, or whatever. Either that or it will sync it. So now we should be able to say something like from bitmap tools import fill region. Actually, let's just say import bitmap tools. It does not like it yet. Maybe we need in the there a top level init? Spelled it right. This thing's just not caught up. We'll see if it works. Let's leave just the import and see if it runs. Module bitmap tools. I think actually we need to add it in here, maybe? Yeah. Otherwise, it's not going to get installed. I don't actually know if that works for the -e part. That might be a thing that needs to be reinstalled, even though we use -e. There we go. Okay, so now it imports, and then does fill region work. So and say bitmaptools fill region. Destination bitmap is BMP. We'll just say maybe 10 by, let's say 40, and let's fill it with the next. So nice. Okay. Exclusive. Let's make sure that the boundaries work. Oh, I don't see any green there, so we should see green if we do this. There we go, good. And then let's put it on the edge. So say display.width -40, display.width 40, display.width. That should be height back there. Bottom corner, and then if we, yeah, so it's exclusive, which means we go to 239. If we do -1, we should get our 1 pixel. Yeah. Okay. I don't know what happens if you go out of bounds. But I also don't know what happens if you go out of bounds on CircuitPython. Looks like here it just works, doesn't really care. Oh, I don't know why that spawned on that screen, but that's what it looks like still. So it's like, it's drawing out here, but it's not visible because it's not part of our bitmap. We'll have to check CircuitPython to know. I'm not sure if that raised an exception on CircuitPython or not. But for now, I'm willing to consider that one done. Draw a line. That should be easy enough. Boundary fill, I actually implemented, and I had a Python implementation. No clue where it would be, or if it exists still. Possible it doesn't exist. I was not keeping backups in Dropbox for a minute from my CircuitPython devices. I am now. Had a hard drive die, and then I have had like PyPortals, which I think is the device that I would have, it's most likely that I was developing on, though I'm not certain. But I have had PyPortals that got their Flash corrupted as well. What is animation thing? Or not animation, but well, we don't really, yeah, sorry, I don't really need collision detection. I just need like draw a line in a bitmap. Again, we could go look at the C implementation. So I don't want to use, so that's the thing, is like I don't want to use, obviously don't want to use PIL. So I want like a line algorithm. or so than a Python code that draws a line. Let's say line algorithm. I think that's one. I see like pseudocode. It's basically plot line is, well, that's the name of their function. And they used x0, y0, x1, y1. We used x1, y1, x2, y2, so we're going to have to change all of those. Anything that's a 1 is going to be a 2. Anything that's a 0 is going to be a 1. XY. So I'm pretty sure that's saying just like draw it. We're going to worry about making this valid in a second. These do need to be indented because this is Python. Plot, that is destination bitmap. XY equals value. So for X in range, we'll worry about exclusive, inclusive in a minute. If E is greater than that, do that. End if, that's not a thing. Okay. Draw in. Okay. It might be good. So let's turn that off. And let's instead say bitmaptools dot draw line, which takes destination bitmap x y x y. So destination bitmap is going to be bitmap. I'll say 0 0. I'll just draw it all the way across. Display width, display height, value 4. Nice. Okay. It'd be nice if this supported thickness, but the CircuitPython one doesn't. And I don't know if that's a thing. What if we tried, say, what is it? Bursenham's line algorithm. With thickness. Another loop and use it to modify the start and end position of the original line in a rectangular direction. Problem is to efficiently find the right starting point. Not draw any pixel twice. Okay. I mean, the answer there is draw polygon, I guess. Okay. We'll leave that alone because the CircuitPython one doesn't support it. That would be nice to have one of these days, though. Draw polygon. So I would need to look at I would need to look at, might need to get a microcontroller. I don't have the camera set up or anything either. But I would need to see, I don't know what that one does for sure. If it makes, I want to say it's a unfilled polygon, if I recall correctly. So I think it's actually just a series of lines. Like you give it effectively two lists of points, and it draws a line from point to point to point to point to point to point all the way through your list. I think that that's what it does. We could also always look at the C implementation. But I'm going to look for another easy one to pick off. I think draw circle should be pretty easy. Ish. Maybe Burnershams? They might have a circle one too. Like I've heard that before, but maybe I'm thinking of a different person. Draw circle. Thank you, Wikipedia. We can copy the docs from CircuitPython in a while too, because the doc string should be the same if everything works out. Draw circle. Let's see, what does that one take? Should be destination bitmap, XY radius value. Destination bitmap, XY. Nice try, but that makes no sense. Radius. Radius is an int. I is. Let's see. Circle. So draw circle. That's another thing. Is that I don't know if that's filled. I kind of need to check on a device. Follow the cord here. Here we go. Actually, to test this, I'm going to take mostly the same code. Actually, I'm going to take all the same code and space open. This is Cleveland Art, I think. CMA Art. Sorry, these are. Spin change. This one. So here we're going to put this, the display. We are just going to use the built-in one. And the rest of this should basically work the same. We'll turn auto refresh off so that we match when we're doing on the PC. No, it doesn't matter that much. Yeah, save that. Okay, I've got no module because that cannot be imported. All right, there we go. Green background, blue line, diagonal. It looks the same as this. So what we're gonna do is bitmap tools, draw circle. That's gonna go to bitmap XY. Let's say 50/50, radius of 20, color. I'll just keep on doing 4. Okay, that is a unfilled circle. That is only an outline of a circle. Again, I don't have the camera hooked up, so I don't have an easy way to show you, but you can take my word for it. Or run the code yourself, in fact. You do not have to take my word for it. I think circle. I think this is what we want. I'm almost positive this is what's implemented in the core as well. I actually have a random branch in the core where this supports fill, which I would like to see. Maybe I should copy that one, find it. But it's again kind of the same issue. I don't want to change the API really. I want to implement what is in the core. Stands today. So yeah, I don't really understand all the math. The pseudocode is more my speed really. So we have slightly longer variable names. T1 is the radius over 16. Oh, this is Jesco's method. Pseudocode? All symmetric pixels. Hmm. Ah, okay. I thought there was some tie-in here. But there's still no pseudocode. Huh. Look at the C implementation. Luckily, this basically has the same signature. It is. It's weird that this is validating in shared module and not shared bindings. Kind of. I think this is kind of weird that this is in shared module. This does validate. Well, this is on min and short max. Interesting. Bug radius. Yeah. Oh, okay. There you go. That's why I had this. Okay, we don't care so much about area. I don't think. I think we basically just want this code. It's not too bad. We could ask an AI thing to convert it. Probably do a pretty good job. But it's also probably not too hard to just do, maybe. Oh. Duplicate? No, we just have X and Y. Okay, I don't know why this is on lines. This, so we have, those are just variables. I guess we don't, I mean, we could make them none, I guess. Or something. Don't need to validate range. Just gonna delete those. And these are lowercase. Probably works the same, hopefully. Okay. In the wrong spot. Faster to just retype those. Any of this. That is a dot. And in fact, it is dest bitmap. We probably are going to be replacing all dests Aiden nations with dest bitmap, but I'll worry about that in a minute because also a bunch of them down there could probably get refactored some. Map debug, we don't need. Actually, we could keep that as like a print maybe for now. Yeah. What happened to the line? All right, so for XB in range 0 to YB, that's actually less than equals, which means we're going to want YB plus 1. I count. Plus, that just happens automatically, so we can do that. Comment this in case I messed that up. Delete it in a minute, but I think it's right. Right pixel, so that's pretty easy. We want to replace that with dest bitmap xy equals value. Maybe that one we will see if our friend ChatGPT has to do for us. Let's see. Have these C statements. I need to written to Python. Have completed first one. Get this Python statement. Can you please convert the rest of them? See if did they include the one that was already done or not? No, like they didn't. Nice. Did they give me the right number of them? 1, 2, 3, 4, 5, 6, 7. 1, 3, 4, 5, 6, 7, 8 because I counted the one that I had already done. And yeah, just scanning through real quick with the eye, those do look like we got the signs and the variables correct to my eye. So thank you, Gippity, for easing up the amount of typing I need to do. I mean, was it less typing or was it just different typing? In any case, it was a lot more convenient to do because this is a lot of like arrowing and deleting and that can be this. This thing will cry about these. Those. B might be, so this is supposed to be inside the loop, surely. C code again. Totally. All right, let us try it out. And copy from here now. Draw. Nice. I will say it is slightly different. Like, this has these weird lines on it. And the one on the PyPortal does not. So actually, I am wondering if something went wrong there. Huh. Yeah, something's definitely wrong there. Maybe we needed those... Maybe we needed those, validate ranges? But that was validate the maximum, like, variable size. I mean, this doesn't happen inside the loop. This is only once at the beginning. And I think this would raise an exception if these got tripped. I don't think it would just skip them anyway. Must be something different about the way is less than or equal to 0 equals d plus 4 times xb plus 6. That seems fine. Else equals d plus 4 times minus 1. Seems pretty much fine. Maybe we don't want plus 1? Didn't fix anything. Huh. This one is a bit more of a long shot. But maybe our friend wants to be helpful on this too. I have this Python implementation of... Yeah, in fact, it's got this. Ham's circle algorithm. And it is drawing extra straight. How many extra straight drawing? Those are probably 4. Probably 8. Probably technically 8. 8 touch. Drawing, let's say, is drawing for extra straight lines, edges of the circle. Identify the problem. Just duplicated pixels are drawn for redundant symmetry points or incorrect logic. Ew. the C code? I moved it to this one. Just resolving that. So this has... Yeah, I didn't catch that before, but that's actually happening here as well. Like, YB gets modified inside of the loop, and YB is also the condition for the loop. Anyway, what does GPT say is the answer to... Instead of looping over XB, maintains XB, YB as coordinates with XB starting from 0, YB starting as radius. And updates both as it goes. The key is you keep drawing while XB is less than YB. That pretty much works for me. Why this fix works, it avoids the issue of modifying. I'm surprised. I don't know why that's working in the C code, though. That's kind of interesting. I mean, I guess the C code is more of a... It's more of a while loop. I guess the Python code... So the Python code probably only executes range once, right? We had range. I bet you this only gets executed once at the beginning of the for loop. That's probably why it's not working. And in the C code, it's a for loop, but like a for loop in C works a lot more like a while loop. So val equals 10, for I in range, val plus equals 1, print I val. Yeah. So it doesn't go infinite in this case. Even though val is increasing and technically like we're never going to get to val because we're always making it bigger. When range got evaluated at the beginning of the loop, val was 10, so we looped through 10 because technically this returned a list or an iterable or whatever that has the number 0 through 9 in it, and that is what we are looping over, not like live looping over the value. Yeah, totally. Yeah. Thank you. We don't really need the entire thing. Well, this is kind of nice too, actually. The way that we had that was a little bit weird. It broke it. Did it? I think it broke it. These are now the same. I think it broke this part, right? These are duplicated now. This is x plus xb, y plus yb, and this is the same thing. I think we basically just want this, truthfully. We don't have xb yet. Actually didn't create any nuns either. Let's take all of these. I do like these. Although, did add a -1. Probably correct, right? We can't really start on bitmap width. Technically, that's outside the bitmap. It's 0-based indexes. I think that's probably most correct. What? Oh. Totally ran wrong thing. Hmm. Does the modifications down here work the same? And then I guess the only other thing I can think is we do want its changed code there. But I'm very suspicious of the fact that that's 2 copies of the same 4 things. We are gonna get half a circle, aren't we? If that, we're not even gonna get that. We're gonna get a plus. Does it? Oh, I don't have that XB. Is that in the C code? C code. Hmm. Oh, but that's happening here. Okay. Price is not infinite, actually. I think we don't need these, but we do need this. I don't know. We'll try those, but I'm suspicious of it being 4 things duplicate. Okay, there is a nice clean circle. Let me try these. I don't know. These definitely seem wrong to me. I mean, if anything, maybe we can get by with only 4 of them? Huh? Oh, can't run this. We need to run this. It does also seem to work. I mean, don't tell me if I take these out, it stops working. What is different about those? There must be something different that I cannot see. Oh, X plus YB, not XB. Okay, they're not duplicated. They are swapped on... They're swapped. I don't know why this says duplicated. It's not actually true. That's weird. Anyway, they're probably the same. I think that it doesn't matter. I'm going to keep the ones that are in the core because they're in the core. But it doesn't really matter. All right, there we go. Circle is drawn in 8 segments. Yeah. I knew that part. But I thought that this code was the same. Well, I've deleted it now, but in that other one, I thought the top 4 things were the same as the bottom 4 things. So I was like, how can commenting out a duplicate of the same 4 things cause it to change? But it turns out they were not actually a duplicate. That was seemingly my IDE kind of hallucinating a little bit, which led to me not really paying close enough attention to the actual code. Okay, we have a circle. This would be another one where it would be pretty cool to support thickness, or fill, actually, would be pretty cool. I did implement C code that allows this to fill as well, but I never PR'd it. It basically took the arcs that were opposite each other horizontally, and then instead of drawing the pixels for each point on those arcs, it drew a line, because we have the draw line function here. It drew a line between those two pixels, and then what you end up with is a filled circle, which is kind of nice, but CircuitPython core doesn't support that, so we're not going to go down that road right now. We have fill region, draw line, and draw circle. What do I want to do next? If we did boundary fill, we could fill this a different way. If we did Blit, I think Blit is probably the next easiest one. Or Polygon's actually probably pretty easy since the way that it's implemented, I'm pretty sure. Let's test this out, actually. I'm gonna try this on the PyPortal again. I know you can't see the PyPortal here because I don't have the camera, but yeah, it's a yellow triangle and a blue sort of quadrilateral. Yellow's kind of hard to see against green, but it's neither here nor there, really. Light is bothering me slightly, so I'm going to change it. There we go. Okay, so those are not filled, and so those are actually just using draw line, I'm pretty sure. Internally. Lost the C code again, there it is. The vector IO polygon is filled, but the bitmaptools one is not. Yeah, that's just calling draw line. And then optionally to draw the last one. So that's actually pretty straightforward as well. Let's do that one next. What do we have here? I mean, I think list, it's really just a list. So x's, y's, value, close, boolean. All right, and then we basically want to loop over all of the points. Our points are split up into two different lists. One list of x's, one list of y's. We want to loop over them both and draw a line from this one to the next one. So one thing is we need to make sure that the length is the same. If length of x's does not equal length of y's, then do that. Now we want to loop over not quite the entire length. I think we want the length of x's minus 1. And then we're only going to do the last one if close is true, I think. So then we'll say this, we'll say cur point equals x's I, get a tuple, y's I, next point equals that. We might need a -2? I don't know. We might need a -2. We'll see. So we have our 2 points, so draw a line between those 2 points. Pretty straightforward. Draw a line, dest, bitmap. The 2 points are... Oh, that's dest. Dest. Dest? X1, Y1. For 0.0. I'm going to put these down to here. Draw the line from there to there. So we're going to have this, but I don't know what needs to go in here. So it should be the last 2, but we might have messed that up, probably. I think that's where the -2 we might need here. But let's see what this does. That seems like what we need, really. Unsupported. Oops, that length needs to be inside, or the minus needs to be outside, I should say. Which is the exact opposite of what I said, but that's fine. I mean, it's not even the exact opposite, it's just not even related. And I do stuff. Alright, ran the wrong thing again. Something is very wrong because... So the red one looks almost correct. Like, the red one is missing the close line, which is exactly what we want. The blue one only has 1 line when it should really have, I mean, 3 if I understood right, but anyway. So if close is true, we want to draw... Oh, right. We don't need -2 because the last line actually goes back to the first point. So if close is true, what we want to do is draw a line between the first point and the last point. So x1, I'll say the first point, x is 0, y1, y's 0, last point, -1. Color is value. Ooh. That did not quite line up correctly. And then the blue one is... I don't even know what the blue one's doing. Ith? Bro. Oh, this has a point size. Wait, what does point size do? I don't know what point size does. It's the maybe, but we have points length also. I don't know what it says does. We probably would have to look at shared bindings. That's probably because it's not. I don't think that's exposed in the API. No. Maybe it's something to do with refresh area. What's going wrong here though? This is. I wonder if this is getting messed up because we're using the same list. All right, let's focus on one. So that should be a closed shape because, like, presumably those are the same points. Why are they different? Print per print. Okay, so our points are 14, 14, and then we went to 60, 24. Okay. Close. This should only happen at the end, but it's happening every iteration. Yeah, that should be outside the for loop. Okay. Now it's not happening there, but they still don't match. So 14, 14 goes to 60, 24. 60, 24 goes to 110, 90. And then this is saying 14, 14 goes to 110, 90. That should put us... But I feel like... Did I swap them? Because that could be like 90, 110 versus 110, 90? Could it? Maybe. Swap them. Yeah. The Y's are always next point 1. I mean, point 1. X's are always 0. Oh, no, that's right. That's right. Fine. I mean, does it matter that we went first point to last point? Like, it should matter to me. Maybe the line algorithm is technically broken if you go the wrong way? I did not adjust the print, so the print is still the same, but now it just didn't draw a line. That doesn't seem good. Hmm. Okay, well, hold on. I still have not called, well, close, is close true by default? I don't know. I don't have close equals true here. I didn't put close in the CircuitPython though, so I think probably true by default. And we know it was true because this was getting printed. Okay, so this just really does not like to be backwards. It's awkward. That means very likely that there are other lines that just won't work, probably. Alright, I gotta run to the restroom. I'll be back in a second. I ran the wrong one again. So, I mean, I could totally buy that that is 110 instead of 90. It does totally look like, but it doesn't appear completely swapped because it just looks further down. What happens if we do this? I think was not the best choice. But I guess we decided that one doesn't work. Well, actually, I think that one didn't work, but also I think these are named. Probably should add, you didn't pass these arguments, you get an exception. That's probably over in shared bindings. Oh, is that my problem? So. Okay. Okay, let's try the 90 theory. Let's try the 90 theory. So makes though because it's at 90. I mean, if we swap, what do we end up with? Further, yeah, okay, further back here. That's definitely not what happened. And it should only be at 90y, which means that it's not like this is 110 and that's 90 and that it missed. Seem like that's the case. Let's try this 110, 90, 130. Okay. So that starts from the same place. So it definitely seems to think that that is 110, 90 everywhere except for when it drew this. And we definitely passed next point 0 for x, 2. Next point 1 for y2. So those are correct, and that basically is making me question, could there be a bug in this? This one we basically just copied from Wikipedia. Okay, hold on though. If I try to draw... If I just draw this one outside of draw a polygon, does it work? So 60, 24 to 110, 90. And x1, y1, x2, y2. Honestly, I probably messed up one of these, right? One of these is probably swapped still. Because remember, I had to change x0, y0 to x1, y1, and x1, y1, x0, y0 to x2. Right. Dx equals x2 minus x1. That looks right. dy equals y2 minus y1. That looks right as well. D equals 2 times dy minus dx. That looks okay. Y equals y1. Looks good. Could we have a range updating thing? Doesn't seem like we have a range updating problem again. So for x, and we don't already have an x, so we're not overriding a variable. For x in range x1 to x2, so that should be fine. That just says plot XY. I assume that means put a pixel there. If D is greater than 0, Y equals Y plus 1, D equals D minus 2 times dx, and if, which we don't have, D equals D plus 2 times dy. Is the plot shown at the right, which doesn't exist? All right, this is probably our problem right here. So we either need two functions, plot line low, plot line high, and then we need the draw line to actually call the correct one and pass in the correct things in the correct order. Or we could do one like this where it is basically figuring it out for you to put them in the correct order. And then maybe still doing some slope testing type stuff here. We want 1 and 2. 1 by 1, 2 by 2. Hopefully, oh, I didn't actually give it the code. Like accepted plot as a function. We're not gonna mess with that, but so our plot is dest bitmap and then I guess this will be changing x1 and y1. Okay. No. There we go. All right, turn off the second one. Okay, that looks better. And then if we do close false, we get I don't know why I keep alt tabbing. I'm alt tabbing as if I need to alt tab to see this, but then this spawns like a millisecond before I alt tab and it hides it. Okay, so now we have 2/3 of a triangle when we do not do close, and we have a full triangle when we do close. So it pays to read the rest of the Wikipedia page and not just copy the first chunk of pseudocode, it turns out. And that was super convenient to change all of these for me. This way I can't make a mistake with them. Not that the Jippity can't make a mistake with them, but in this case I think I'm probably more likely to have made a mistake than it was. But we'll see. Okay, so line is working, which means polygon is working. Let's turn back on the other one. Drawing 2 again. That one was all messed up. There we go. Yeah, now that looks the same as on the Pi portal. Perfect. Okay, very good. All right. So we have fill region, draw line, draw circle, draw polygon. Let's do blit really fast, because I think blit should be pretty easy. In fact, blit we saw earlier, there is an implementation of on bitmap. We could just take this one. And it should be pretty much the same. Oh, we don't want array blit though. Array blit should be, I guess, should be easy once we have blit, because it's just use an array instead of a source bitmap, maybe? I'm not exactly sure. I don't think I've used array blit before. Okay, one thing that is different is there's a skip source index and a skip dest index, where here there's only a skip index. I think one or the other of those was new. So we'll need to make sure to add the other one. But everything else looks pretty much basically the same. It's in a different order, like source bitmaps down here. That's fine. Yeah. Def blit. That is a lot of arguments. It is a long list of arguments. I guess it's kind of a lot also. We want. I don't know if we want that. Okay, so anything that was self is gonna now be dest. Yeah, anything that was self is gonna be dest. Oh, interesting. Skip index. So that was if skip index 1, if it's none, or if this pixel color, which we got out of the source. Wow, that is code formatting right there. So this was the source. This is skip source index, it should be. This is checking the pixel that came out of the source. And then dest, I guess we will need to see the C implementation. Tool split. So skip dest index. Like it has a boolean for if it was none as well. Oh, okay. I mean that's dest index. Interesting. I don't know. I don't quite remember why that was added exactly. Skip dest index. Why you would want to do that? So we need to read a pixel out of the destination as well. So if skip dest index is none, or dest, so no map this pixel have to run. It was useful to be reminded about those pesky lines and circle drawing details. Thanks for the stream. For sure. Yeah, take it easy, C. Grover. We will see you later. You have a nice day. So this is saying get pixel value for, well, this is the source though. I see. If we need to check only the source one, then this branch handles it. And then if we need to check both, then this is the logic. And it already checked for none here, so it doesn't check for none again. And we need to read YD index. We have that? No. I mean, we should have that, right? Because so this is the destination. This is the pixel where we're about to put something in. So that's the pixel we want to read. So read that pixel, and if it is not equal to skip dest index, then do this. Otherwise, don't. And this needs to be here. Does the nuns work, right? I think the none should be fine, right? So if that's none, then it's true and we go in. And if that's none, it's true and we go in. And if that's not none, we check this. And if that fails, then we don't go inside. But if that succeeds, we go to here. And if that's not none, we check that. If that succeeds, we go in there. I think that should be the same logic, even though on the C side, it's actually split a little bit differently like this, but I think that's the same logic. In my head, this is nicer, so I'm going to do that. This whole thing is just really gnarly, truthfully. Maybe we can... I think we don't really need this. And in this case, we're not inserting anyway. Well, I guess it said direct index. Okay. Okay. Let's see. We got about 12 minutes left. I think I can test this by like blitting a chunk out of this just randomly over here. So bitmaptools.blit. So we're going to say both source and dest are bitmap. And then we need what? We need a whole lot of things. So XY, the horizontal, so the location where we're going to start our cut from, our copy. I think of this as copy paste essentially. So I'm going to say just like maybe, I mean, let's just start at 0, 0 to keep it simple. 0, 0, and let's just say 80, 80. Oh, well, we need, so wait a minute, no. So XY, that's where we're gonna paste into, actually. No. Yes. Yeah. That's where we're gonna paste into. So that we actually do want bigger. I'm just gonna say like 100, we have 320 by 240. I'm gonna say 120 by 120. Just to get that kind of to the bottom right quadrant, so to speak. So that's where we paste at. And then X1, Y1, so this is the box that we are gonna cut. So I wanna cut 0, 0, and we'll just go up to like 80, 80. X1, Y1, X2, Y2. Okay. And then what else? We need the skips, but those can be none, so let's try that. Okay. I ran that on the PyPortal accidentally, but it totally did work. It copied almost the whole triangle and like half of the quadrilateral. Nice. Could we test the skip somehow? Yeah, so we could skip, let's say skip source index of red. So let's copy only the blue thing and not the red thing. So the red thing is index 2, I think, yeah. So skip source index. Nice. Okay. So that copied only the blue pixels. Well, it skipped the red pixels. It actually technically copied the green pixels as well. Skip dest index. So we could try skip dest index of green, but like that's just going to make it not draw anything. We can test if it's going to work though. Target index. Skip dest. Yeah, okay. So that copied, well, it pasted nothing because it skipped every pixel. We would need some more interesting bitmaps in order to test that more fully. It would be nice to probably draw, in order to test this, actually thoroughly, it would be nice to draw a checkerboard of like alternating squares and then skip one of them, right? So you would end up with your shape, but like only in the black squares of the checkerboard, for instance, or only in the white squares of the checkerboard. Well, checkers, I think, are usually red and black, but chessboard. Cool. Okay, that was easy. Blit seems to be working. I think I will stop there. So what I'm going to do is get back to here. I'm not going to run pre-commit right now. I am just going to save this stuff and commit locally to bitmaptools. I could push actually as well if anyone wants to mess with this. But I won't PR it yet. I'll wait until we get more stuff implemented. But that's not bad. We got 5 of them. We got 5 of them done. They're the 5 easy ones, but I'll take it. Let's commit that. Starting bitmaptools implementation. Hopefully I have git remote. Yeah. All right, there we go. That is pushed up to my fork of Blinka DisplayIO. We got, is that half of them? I'm not sure, but it's, like I said, it's the easy one. So even if it is technically half the functions, I don't really call it as half complete because the other one's gonna be a bit harder. It might be worth a try to just feed the C implementation to ChatGPT or Cloud Code and see if it will do the Python implementation. Or maybe even give it the doc strings, since the doc strings represent Python functions. Or maybe we could give it both, the doc strings and the C implementation. In any case, I'm pretty happy with what we got so far. But I am going to head out for now, so thank you to everyone watching. Has my chat been stuck the whole time? No. Okay. I don't know why, but the preview, we did the stream blink out at one point and then come back. I don't know. Anyway, it's not really important. The preview that's in Restream is showing me basically just the first frame, I think, how the chat was at the beginning of the stream. But that is neither here nor there. In any case, I hope everyone has a good rest of your day. Good weekend. I will be back at the normal time next week around 10 a.m. Central Time. As far as I know, Scott is still around for deep dives. He will be taking leave here in a couple more weeks. I think he said three or 4 weeks, something like that. Maybe the end of April, something. I don't remember the exact timeline, but starting then, I'll be doing deep dives for a while, but we have a couple weeks to go. So next Saturday, I believe that I should be here at the normal time. I will see you if you are here as well. Otherwise, I will bid you farewell. Good day. Goodbye. Thanks for hanging out. See you later.